Hello and welcome to PMCD Maths Teaching, and this video is about how to really complete the square to solve quadratic equations. Okay, so my approach here, which hopefully takes account of this rationale. Okay, so a little mission. When I first started teaching completing the square, I used to stand at the board teaching, and I'd be there sort of 10 minutes perhaps going through a whole question, and to sort of look at the students in, right, okay, red, amber, green on this, and a lot will be red, maybe a few amber, a few green, maybe, but I'd lose a lot of them, because there's multiple steps there to think about, and the concentration or the ability to follow that a set of complex for anybody really. Once you get past 3 or 4 steps, you are struggling. So the aim of this is to get them to do the work, and this is a good idea with as many things as possible. Actually, if you can get them to do a bit of thinking and the work first, you can top it up with new stuff from their point of view, and it doesn't seem so difficult. So I found this quite successful. Okay, so starting the lesson, really sort of give a reason why we might do this. So the problem here, I'll give some practical application for this, this involves setting up a quadratic equation and solving it. So it's starting to push that problem solving aspect there as well. This bit here that's covered, I've just covered up the bits that really I wanted to push them, go to the length and width of the pool, but this sort of, if they needed it, I could then bring in, okay, find expression for length and width, find expression for the area. So there's little intermediary steps. This one's solvable by using factorization, so not too much of a problem. And then if you look at the next one, almost identical, except the area is now 95 centimeters squared. And when they come to solve this, they're going to find a problem, because the quadratic equation on this particular case was at x times x plus 6. So we've got x squared. Where's my pen? Let's have a look. X squared x times x plus 6 has to be equal to 95. We end up with x squared plus 6x equals 95. And x squared plus 6x minus 95 is equal to 0. Now, obviously, the problem with that is it doesn't factorize. So what does that mean? There's no solutions? Well, there are solutions. Obviously, there are solutions. And we're sort of giving them reason, a purpose for doing what we're going to do today. And, as we go further on, I always like to emphasize, if you can complete the square, you become good at it. It's quicker than using the formula when they actually get to that point. Okay, so here's the card sort. I will attach this in the resources as well, but you can make your own here. And all they're doing here is matching cards, matching pairs here. Now, normally I like to put in a red herring in there, or one that doesn't match. I don't like them thinking if they've got an even number of cards at the end, they can just pair those up without thinking about it. So I'll chuck something in there to make sure they're thinking all the way through this. And I think, we'll explain which one that is anyway. So what they, in terms of administration for this, because, making card sorts, which I'll do another video on. Anyway, I think most of you probably know how to do that quite effectively, but, I found I can share my method of doing it anyway. It's quite quick. But yeah, once I've got it, I will do this myself or email it to Graphics, and I will get on 16. For me, the biggest class I have is about 32. So I'm sharing one between two. I need 16 copies. And what I'll do is try and, if your school's got it, 16 different colours of card, ask Graphics to print them on that. I don't ask anybody else to cut them out. And then in the first lesson, I hand these out, one between two, and they cut them out for me, and I'll give little elastic bands so we can collect them in at the end. So trying to minimise my workload a little bit as well, whilst generating useful resources can be used again and again. And yeah, so that's my idea for that. Okay, so what ones do we look at then? The ones I'm going to look at here is these ones. I'll put some dots on here. So I want to just sort of reference things as we're going through here. Ones with red dots. Once they finish this, we do get matches. Okay, so we get this one here. Let's just do the right colour. we get this x plus 3 squared. Now they'll start noticing this pattern. There's something they can actually talk about here, even though you're not actually explicitly saying, you don't have to ask about this because we're going to do a question in a minute. This one here matches with this one here, and we can discuss why that's true. I.e., you know, we get x plus 3 squared gives us a plus 9. Take away the 9, that actually eliminates that plus 9, even with the plus 6. We end up with x squared plus 6x plus 6. Okay, so when they move on from that, they then go on to, well, hold on, I can do this a little bit better. If I was actually solving this one, if I want to write this one in a particular form, why are these two the same? I should be using blue now, shouldn't I? Why are these two the same? Well, how would I know what to do there? Could I do that without actually having to expand that? How would I know how to write x squared plus 6x minus 2 in this form? And they start noticing, you know, obviously it was half this value here, because when that, and they've gone through the expansion of that. They've already done x plus 3 times x plus 3. So you don't have to explain that, that's there. So they say, okay, I've got x plus 3 squared. Okay, I want minus 2, but I want minus 11. Sorry, I've got x plus 3 squared. What's that going to give me? That's going to give me an extra 9, but I want to get down to minus 2. So it's given me a 9. I want to get to minus 2. I'll have to subtract 11. Now, the admission here is not the way I originally taught this. This came out of what students would say to me, because I thought they would say, oh, look, it's given me a plus 9. The other way of thinking about this, x plus 3 squared gives me a plus 9. So I'm going to take away 9 from it to get the x squared plus 6x. And then it's got a little minus 2 on the end, which gives me the minus 11. So I thought that's how they're going to go. But, you know, obviously responding to what they've done here, they've said, oh, it's given me a plus 9. I want to get to minus 2. I have to subtract 11. So it was a much more efficient method. I hope that makes sense. I'm going to go through an example in a minute if it doesn't. The green one, just to say, I had a little red herring in there, didn't I? If you look at it, this green one here matches with this card over here, very well circled. X, because, you know, we end up with, take away the 60 and subtract 2, that'd be true. But look, this is for those, for sometimes people, they get a bit blasé, x minus 4 squared, and they start writing, oh, x squared minus 8x minus 16, okay? So this here is thrown in there just to expose that little misconception. There's very subtle differences there, which means there's an odd one out, there's going to be an odd card out anyway as well. You know, do it yourself. Best thing is do it yourself and see if you can make out what I'm saying here. So what's the aim of this? The aim of this whole card sort is, if we go back to this red one again now, here, I want to be able to say, okay, what's the brackets going to be? Well, it's going to be x plus 3 squared. Okay, and this is their explanation, what they're saying, and we need a plus 6 on the end. Well, that's a plus 6 I want on the end. So what am I going to do? That gives me a plus 9. So I need to take away 9. If that gives me a plus 9 and I want to get to plus 6, I just have to subtract 3. And if you look, all 3 red expressions are the same now, but that's the one we're after. Okay. But you know, you can go with the flow with what your class says, but that's what I found with that one. Okay, moving on then. So we get to do some questions now. And again, you know, mini whiteboards I use a lot here to do this. They all try this. So, okay, what's the bracket going to be? Well, it's x minus 3 squared. Okay, but I know that gives me a plus 9, and I want to get to minus 8. And you know, and you have to believe me on this. When they've done this card sort, they do this knowing about that there's plus 9 on the end of this expansion very, very quickly. Whereas if I was teaching this at the board, you know, they'd be starting to sort of to lag a little bit by this stage because we've already done a bit of work on it. Plus 9, I want to get to minus 8. What do I have to do? I'm at plus 9, I want to get to minus 8. You can say I can go down to 0 by subtracting 9 and then subtracting 8. Okay, so they could say it's x minus 3 squared minus 17. So minus 9 will get me down to 0. Then you subtract 8 to get to minus 8. That's one way of thinking about it. Or as a lot of them started doing, as I said, they go x minus 3 squared is, that gives me a plus 9, and they do it in their heads. I want to get from plus 9 to minus 8, I'm going to take away 17, and they get there straight away. And all of a sudden, you know, completing the square suddenly becomes a bit easier. What do they do with this, though? What do they do with this? Well, before going on, let's have another go at another one. I'll get them to do another example of that. I'm just going to say this again for perhaps any of you that I've not quite picked up what I've said there, because maybe I've not explained it as clearly as I could have done. X plus 6 squared, that will give me an extra 36, but I want to get down to -5. And in their heads, they're going to go, oh, I'll take away 36 and take away 5. I need to subtract 41 to get that to work. Okay, try this. Believe me, it will go well. Then what you're doing then is that you can top up now, really. Once you've sort of made that link, so, well, okay, second phase of this now is to solve the equation. So what do we do? And it's all about, you're just doing stuff that you've done before with equations. You're making X the subject, and that'll lead down to your solution there. The only thing I would say about this, I suppose, a little bit of emphasis needed on the positive and negative root of 41. You subtract 6 from both sides. The way that they would write it, a lot of them might write root 41 subtract 6, which can cause problems. They sometimes that starts creeping over, and we have problems there. So getting that idea that we're going to put that constant first, that constant value there, that's what we've got. And what does that mean? There's two solutions: 6 plus root 41, and x equals 6 minus root 41. Keep pushing with this. What's root 41? That's about, what is that? Well, root 36 is 6 point something, 6, so it's going to be 6 point something. So we're looking at about 12 point something, yeah? And 6 minus 6 point something is going to be negative 0 point something. So this is going to be important for the subsequent activity we're going to do. But keep pushing. Obviously, it depends on your class. You can assess that. Sometimes you may not want to push that hard at this stage. Other classes, you may go, right, yeah, we'll go straight into the graphical side of this. Okay, so that's pretty much the process of doing that. The following activity for this, sorry, actually going on before that, I was saying, why is it called completing the square? Again, the explanation here of what's actually happening with this. Why is it called completing the square? We always say it, very confidently, but what does it mean, completing the square? Well, let's go back to the equation we had earlier, x squared plus 6x minus 2 equals 0. If we just forget about the equation a bit, we can just look at this x squared plus 6x part here. If we're working out the area, we'd have a 3x, a 3x. But what would we have to do to make it, what would we have to do to that x squared plus 6x to make it a whole? Okay, so that equation's got x squared plus 6x, and so is this square. What do I have to do to my equation to complete it, to make it square? Well, I'm going to have to add this missing part here, the plus 9, isn't it? Okay, that's the bit we're going to have to add on the end there to make sure it's perfectly complete. Okay, so how does that come to solve what we're doing here? So what we've got here, we've got x squared plus 6x minus 2 equals 0. Okay, x squared plus 6x can therefore be written as, just come on to this in a minute, that's x plus 3 squared is what we get. Okay, so if we write it a little bit clearer, I'm just going to show this. X squared plus 6x plus 9, which has been completed, is equal to x plus 3 squared. It's shown that the square is completed, which means x squared plus 6x is x plus 3 squared subtract 9. So the form we often ask for is not actually showing very clearly it's completed square, but that's the explanation of what's happening. So we can actually say this bit here, if I was solving it using this method, I could say, well, look, that's x plus 3 squared minus 9. I've still got the subtract 2 to come down, equals 0. And, we're away then to the solution. Now, this isn't exactly the way that the students evolve that answer from this card sort, but it's an explanation for them to understand, yeah, you could do it this way if you wanted to, and that's why it's called completing the square, because that x squared plus 6x, that's what we have to do. So x plus 3 squared, x squared plus 6x, to complete the square, we have to have plus 9. This is the relationship, which means x squared plus 6x can be written in this form. Okay. Okay, follow-on task here. Let's move on. So these are just practice here. So then, it's a little worksheet. Again, I'll attach this as well. So I get them to do the working in here, and I get them to sketch the graph. And so this is why it follows on well from sketching quadratic graphs. So you're going to see graphs with, here, which is, I think, is quite impressive actually, where your roots are, they're going to write them as, 2 plus root 3 and 2 minus root 3. You expect to see irrational roots there, but it's the power of seeing that on a graph and the fact that the graph is showing those solutions and reinforcing this idea of where roots appear, how we can spot roots on graphs. And yeah, I mean, the turning point probably, it's not going to be possible to draw that, but you should be able to see where the turning point is by thinking about where these roots are in relation to the y-axis. Okay. The turning point is not always going to be on the y-axis, is it? We know that. So you need to make sure that if the turning point is supposed to be over this side, then it appears that side, not always turning point on the y-axis. And yeah, there's a few there, and then it goes on to a bit of a task with challenge where the coefficient of x squared is greater than 1. Challenge them. Can they work out what to do with that? And again, depending on the class, you can go with that. And the general solution, which if we did that and we rearrange it, we know we get the formula from that. So completing the squares the boss, the formula is just like the cheats method, really, isn't it? So if they're good with completing the square, and there's no reason why they shouldn't be, then that hopefully becomes their preferable method. And it's only when we get these coefficients of x squared greater than 1 that they would go and use the formula. Okay, as I say to them, I want them to see, be so good with their mathematical techniques that picking up a calculator is too much effort because I'm in the flow of what I'm doing. Not as soon as it gets difficult, I look at my calculator. Okay, I hope that all makes sense, and I will see you next time. Okay.